The ping is allowed for this IP address range. The database access port is allowed for this IP address range. SSL versus SSH, all that stuff, what is allowed from that specific IP address range, you would put it under security group. What needs to be denied, you would put it under the ACL list. I hope that is clear for you guys. Now, these are the very important components, right? The other optional components are Internet Gateway, Elastic IP address, endpoints, peering, and network address translation, NAT instance, and virtual private gateway. Now, Internet Gateway is basically is used whenever you have a private subnet and you want to allow your private subnet, let's say for some installation on an EC2 instance which is sitting behind your private subnet. So you have to define a route outside of your private subnet for that EC2 instance to maybe have some installation of MySQL or whatever. So you would actually put a internet gateway so that your EC2 instance, which is your behind private subnet, is allowed to get out of the private subnet and access the internet for whatever installation or whatever reason it is. The other thing is Elastic IP address. So if you want to assign a specific IP address that stays with the machine, you can also define an EIP, Elastic IP address. Let's skip the endpoints. Peering is basically if you want to define two VPC to talk to each other, you can define the VPC peering, right? So there might be instances where your dev environment and QA environment need to talk. So what you need to do is you peer your VPCs and by using VPC peering, and then allow the two to talk to each other. Net instance and net gateways, again, they are kind of similar concepts where you can have an instance where you install an internet routing out using either a net instance, which is not really recommended, or I'd say it's an older technology. Then you have the net gateways, but both can be associated in order to get out of the VPC or the private subnet. You can install that net instance or net gateways. Virtual private gateway, again, this is just a gateway for VPN, or if you want to get the connectivity from your on-premise to AWS instance, and if you want to establish a connectivity between the two, you may want to define a VPN, a VPG, or customer gateway. What this does is basically allows the connectivity between your on-premise and AWS. A good example would be where there are certain servers that are sitting on your EC2 instance that doesn't need to be exposed outside, but your employees need to have access to it, and it's that server sitting in AWS behind your VPC. But the resources are sitting at an office, remote office, and they want to access that server. How do you do that? You can define a customer gateway, you can define a VPN or virtual private gateway, and that makes a connectivity between the offsite office and also the AWS VPC. And that connectivity basically is secure if you're using a VPN, for example, using the tunneling. And that basically allows the connectivity to be established between the offsite office space and also AWS VPC. So again, depends on the need. There are cases where the offsite or remote office location need access to the instances on the VPC, and that is the best way to actually establish that. Okay, these are the optional guys, and then these are the majors. So without this, you can't really have a proper VPC connectivity. Some of these things we'll talk about it, where whenever you set a EC2 instance, by default a VPC is set for you. The routing table default is set for you. Dynamic DHCP is set for you. A security group is already set for you as a default. ACL is set for you. Some of these things are already set up whenever you are setting up an EC2 instance within the AWS environment. Okay, let's talk about the examples within the subnet and VPC. So this is your AWS environment holistically, right? If you look at it, then you have within that AWS environment, you create a VPC, right? Virtual private cloud, right? And so once you create that, then you have those subnets, right? So this is a subnet 1 and this is a subnet 2, right? And these subnets that you can define it as a private or public, right? And you define these CIDR addresses, right? So a CIDR address would be something like this, right? So a VPC is defined 10.0.0.0 /16, right? So what does that mean? So let me just jump over to the calculator real quick, and so that I can show you that. Okay. Can you see the calculator, Shane? Can you confirm?
Yes.
Okay, so it was defined as 16, 10.0.0.0 /16, right? So the way you find out how many addresses you have in that CIDR address block, you take 32 minus 16, right? And actually, let me just view. And then basically you take 2 to the power of 16. 65,536. So this is the address range you would get if you define your VPC to be 10.0.0.0 or .1 /16. So you'll get 65,000. Now, if you want to limit it to, for example, a less block of IP addresses, like again, let's say you say 10.0.0.0.1 /24. So the way you find out how many addresses you will get, or how many IP addresses will be assigned or can be assigned in that VPC, would be 32 minus 24. So it's 8. And then you take 2 to the power 8. So you get 256 IPs that can be defined in that VPC. Okay, that's how you actually find out what are the IP address range you will actually get when you define the VPC address range. Okay. All right, let me just go back here. Okay, so in this case, for example, this VPC is defined at 10.0.0.0 /16, which means, again, 65,000 plus address range within this entire VPC. Okay, now here you see there's a subnet 1, subnet 2. So what's happening is, like I said, the IP address range was from, excuse me, 10.0.0.0 /16, which gives you 65,000 plus IP address range. Within that IP address range, you can define your subnets, private subnet, public subnet, whatever you want to define it. And then you can further say, okay, this subnet would have this IP address range, and the other subnet would have this IP address range, right? You can have private, public subnets within that VPC. So in this example, for example, is saying, I'm going to start with 10.0.0 /17. So again, you will take 32 minus 17, and whatever that number is, you take 2 to the power of that number, and that is the IP address range for this subnet 1. This IP address range would start 10.0.128.0 /17, but note that it is starting from 128, right? So you will take that, and then you will start from 128, and then 0 it will be actually incrementing the number from here, 0, 1, 2, 3, 4, 5, and so on and so forth, taking all the ways up to 32 minus 17, whatever that number is, to the power of that, and that would give you that range for subnet 2. Okay. So this is how you actually get the IP address range using the CIDR block, right? The way that it happens is basically it gives you a main routing table, and this is where it would define the address range. So now, which leads me to the routing table discussion, right? So once you have defined your VPC, you define your subnets, saying, okay, well, these are my subnets. The routing table makes an entry saying, okay, whenever there's a call coming from outside or internal AWS, how do I translate that into which subnet I need to go, which IP machine that I need to go and hit? This routing table is basically mapped, and it's created automatically, right? And it says, okay, all of this IP range, 10.0.0.0.0.16, is local IP address range, which is defined over here. So this is the VPC that I'm going to be using whenever the request comes in. So request comes in, main routing table gets hit. Main routing table says, okay, where do I go? It says, okay, well, this range is defined local to this VPC, and it basically tries to translate, okay, this is the IP range. I'm going to go in, and I'm going to probably hit this machine on this IP address. So this routing table is basically used for that.